You can visit our website for the commands in the videos. If you want to purchase other study materials like packet tracer files and other course guidelines, then you can email to us. Follow us on Facebook for further updates. Please do like, share, comment and subscribe so I can quickly deliver more videos on various topics. So here are some OSPF troubleshooting and verification commands. So first you can check show IP route. To view the routing table, you can use this. And to view only the OSPF routes, you can use show IP route OSPF. And then show IP OSPF interface command. So by doing this, you can see the MTU value. The MTU value must match on both sides of a link, right? Generally it should be like 1500 like that. And then you can check show IP OSPF neighbor to figure out what are the OSPF routers which has been formed neighborship with this router. Okay, show IP OSPF neighbor. And OSPF maintains a database table as well, so you can try it by show IP OSPF database. And then to reset the OSPF process on all routers, you can simply type clear IP OSPF process, which you should enter in the privilege mode, right? All these show commands are on privilege mode, and also the clear IP OSPF process also should be entered in the privilege mode. And to remove the OSPF process, you can simply write no router OSPF 1. For removing the OSPF process ID 1, you can use this no router OSPF 1. Okay, so the OSPF 1 process would be removed. You don't need to remove the area command, just simply remove only the router OSPF 1. That would be enough. The OSPF process will be removed, and the neighborship also will be removed. Okay. And then to remove the particular interface from OSPF, you can try interface FA01, and inside that you can type no IP OSPF 1 area 0, which is like when you try the show run command, you will see inside the interface IP OSPF 1 area 0 like that, it will show, right? So to remove that, you just have to go inside the interface FA00 like that, type it. So now you are in the interface. So just type no in front and paste the remaining command. When you most of the time when you wanted to remove something, you just write the show run command. So it will be displaying on it. So copy the particular command and go to config mode and type no space and paste the command you copied. Okay, so mostly this works with all the Cisco commands. I think most of the Cisco commands are removed by just simply typing no in front of it. Okay, now to demonstrate the OSPF no route OSPF 1, I can use the packet tracer. So here we have configured OSPF already. So if you want to check, just simply enter inside the packet tracer, enable show run space. You can see OSPF is there inside the interface, and router OSPF 10 has been configured. So now I wanted to remove this router OSPF 10. So simply I will copy it and go to config mode and type no space and paste the command and enter it. That's it. So next time exit and try show run, you can see there won't be any OSPF. Earlier it was there, now it's not there. We have removed the OSPF. When you remove the OSPF, you won't be seen by the other router. Why? This neighborship has been removed. There is no OSPF running here. So just fast forward a few times and go to the router, and you can see when you remove the OSPF there, it's showing fast Ethernet from full to down state, which has been neighbor interface down or detached. Okay, interface down or detached, which means that router has been removed in this router's neighborship table. So type enable and show IP OSPF neighbor. So now you can see the router has been removed in its route table. Okay, so there is only one neighbor it's showing, which is the other router here. Okay. 40 dot, you can see, and the router ID address is 30.10.10.IP address. So which is here. 30 dot will be coming here. Okay. And next I'll be showing you how to remove the IP OSPF1 area command. So go inside the router, show run. So you can see in the router, inside the interface, you can view the IP OSPF10 area 0 command, which is coming under interface FA00. So copy it and go to config mode. Type interface FA0/0. Type no space, paste the command. So you are removing the OSPF command entered inside the interface. Okay, enter. So once after you entered it, you can check process 10 40.IP on fast Ethernet 00 from full state to down state, which means when OSPF is complete, it will be remaining in full state. When OSPF has been removed or detached, it's gonna be in down state. Okay? That is what shown here. So now let's see how the OSPF neighborship is being formed. Okay, there are 7 states involved in OSPF neighborship formation. Okay, so initially when there is no neighborship packets exchange, the routers are in down state. Okay, so that is what shown here. When OSPF is not in process or not configured, you will call it as down state. Then the routers are going to be in init state, which means one of the router is going to send the hello packet to other router, to the neighbor, which means the connected router, and kind of like saying a hello, which hello packet is going to include the area ID, hello interval, dead interval, MTU, and everything, stub flag, everything. Okay, and then if that opposite router is replying with another hello packet, which means when the 2 hello packets are exchanged, the routers are now in two-way state. Okay, so remember, initially down state, then one hello is sent and second hello is received. Now the routers are in two-way state. Okay, so next you must know what is LSDB, linked state databases. Okay, which means each and every router, when you configure OSPF, it is going to include what are the route it knows. For example, in this router 1, it has a LSDB, and also here another router, the neighbor router, you can consider that. So it also having its own LSDB, which means the router 1 is going to have the routes in its route table regarding his known networks, these 2 networks. Okay, and router 2 is also going to have its routes, known routes, which means the known networks like this one and this one. Okay, so you can consider the LSDB as a route table kind of. Okay, the known networks are there. The summary of the LSDB is DBD. You can see it here, which means database description. Okay, so once after the 2 routers exchange their hello packets, which means once after they are in two-way state, they started exchanging the DBD, which means they are known routes. Okay, so by doing this only, they can communicate and compare and see what are the networks the other router is known. Okay, so that they will compare and they will find the routes to remote networks. Okay, which is step by step we will see how they are doing it. Okay. So in the database description, initially when you exchange the hello packet, it has the priority value, right? So from the priority value, highest prioritized router will start exchanging the route first, DBD, okay, which means highest router ID or highest IP. As you know, we already discussed how the router ID has been selected. If there are loopbacks, the highest loopback IP will be the router ID, or else if there are only physical interfaces, the highest active physical interface would be selected as the router ID. Okay. So now what's happening? After hello packet exchange, they are in two-way state. Now they are going to exchange the database description. So now they are in the X start state. So database descriptions going to be exchanged. So the highest router ID router will start sending the DBD first and then the other opposite router. So now the DBD has been received to the other router. So what happens? Both routers are going to compare the DBD with their LSDB. In the LSDB, what they have? They are known networks, already known networks. So they are going to compare that networks with the received DBD. So in that comparison, they can find out what are the missing routes, right? What are from the neighbor, what are the missing routes are there. So they receive the DBD and they are comparing with the LSDB. And next step, this step is called exchange state. Okay, DBD exchange has been completed. After the completion, so now let's say for example, one router is figuring out what are the missing routes, right? Missing networks, unknown networks or remote networks, whatever you can call it. So what it's going to do is, it's going to request the particular path for the particular route for the network, the missing network. Okay. So what's happening here is, it is in the loading state. So there are certain packets, LSR, LSU and LSACT. LSR is link state request, LSU is link state update, LSACT is link state acknowledgement. Okay. So in the loading state, once the DBD has been exchanged and compared and it found, let's say for example, router 1 found 192.168 50.network is missing in its LSDB. But router 2 knows about that 50.network. So in his DBD, database description, router 1 received it, the 50.networks router. So he is going to ask the router to send me the route to the 50.network. Via what? The LSR packet, link state request packet, which means how can I reach that 50.network? Please send it to me. Okay. Likewise, think like that. So now that particular packet has been received by the router 2. So router 2, what it does is, it will include that particular network's route, and also if there are many networks requested, it will include each and every network routes in one LSU packet, link state update packet, and send it to the router 1. Okay, you can see it here in the 6th position. Okay, so when router 1 receives that LSU, he will reply via the link state acknowledgement. Okay, LSACT. So it's going to tell, I received those missing routes, and it's acknowledging it. Yeah, I received it, like that. Okay. So now the router 1 knows each and every route in the network, right? So he will update his link state database. And also, this is the same process going to happen on other routers as well. And neighborship has been formed. Okay. After the network convergence has occurred, it is going to be in full state. So OSPF protocol is in operation. Okay. In the OSPF neighborship formation, routers exchange hello packets every 10 seconds, the hello interval. So this router 1 will send hello packets 10 seconds, and the router 2 also send the hello packet every 10 seconds. For example, let's say when router 1 sent an hello packet, and now it's being like 10 seconds past. So the router 2 will wait until it receives an hello packet from router 1 up to 40 seconds. Okay, total maximum the router 2 will wait up to 40 seconds, which is the dead interval. After the 40 seconds, if router 2 doesn't receive any hello packet from the router 1, the router 2 will remove the neighborship of router 1 from its route table. Okay, because router 2 will consider this router 1 link has been down or something like that. Here's how the OSPF area concept goes as. For example, area 0 is the backbone area. In any OSPF topology, backbone area is the must. In the backbone area, the routers are mentioned here as shown in these routers. All the interfaces are coming under area 0. Here also in the router 2, you can see all of its interfaces are in area 0. So you can consider it as a backbone router. Okay. And the other router you can check here. In this router, one of its interface is in area 0 and the other interface is in area 1. So we call this router as area border router, which connects other areas like area 1, 2, 3, whatever with area 0. Okay. You will understand this area border router better by explaining the function of it. For example, let's say here in this diagram, you can see this area border router is having the summarization of 192.168.20.0/24. Okay. In this router, you have connected other routers like in area 1 20.0/27 and also 20.32/26. Also next subnet 20.96/25. Okay, so /26 is there, /25 is there, 27 is there. So if you advertise all of these routes one by one to area 0, there might be little time consuming and complication. Okay, so to avoid that, you can summarize this network as 192.168.20.0/24, and this summarization has been advertised to the area 0. Okay, so by doing this, the network convergence time is getting low. So which is one of the benefit in OSPF. So these kind of routers, which comes some of the interfaces are on other areas and which connects the area 0 by one interface. Okay, so we can call it as area border router. In the other hand, you can see ASBR, which means autonomous system boundary router. Okay, for example, in this area 2, you can see it's like it's configured with EIGRP or BGP. We mention it as autonomous system 2 in this side and autonomous system 1 in the first side. For example, autonomous systems are like which comes under a particular administrative domain. For example, your branch 1 is coming under one autonomous system and your branch 2 is under another autonomous system, and your ISP, internet service provider, is going to be in another autonomous system. Okay, so when you connect these autonomous systems, when we configure BGP, we use autonomous system numbers in order to distinguish between the different autonomous system, different admin domains, and connect them. Okay, so this kind of connection, router which connects other autonomous system protocols with the OSPF protocol. So this kind of router is considered as a autonomous system boundary router. Okay. Also, the remaining routers here in area 1, we can see this one, and the other one. All these routers interfaces are in area 1. It doesn't have any interface on any other area, right? So this kind of router is considered as internal router. Okay. The internal router contains only the route information which comes under the particular area, which means the area 1 in this case. The area 0 routers going to have route details of the entire topology, which means area 0, area 1, area 2, whatever. And area border router has the route information of area 1 to inform the other area 0 router. Okay. So area to area route information is being stored in area border router. Okay. So far we have seen the static routing and dynamic routing labs. So now we'll just have a look at the theoretical background between the static routing as well as the dynamic routing. Okay. When you take the static routing like RIP, there are some limitations. You can't go beyond the 15th router. You can't configure RIP because, as I told earlier, RIP uses hop counts, which means the router counts in between. So up to the 15th router, it will work fine. Then it will consider the 16th router as there is no router, no path to destination. Okay. Also, RIP uses periodic router update to send and receive router updates, advertisements, so that they can form the neighborship. Okay. So in this case, routing loops might occur sometimes. Okay. And link state routing protocol, when we call for OSPF, it uses open shortest path first algorithm. So in OSPF, the routing updates has been sent only when the network has been triggered, like network change occurs. Okay. So advertisements are flooded among routers. So in order to avoid this, we use the area concepts in OSPF. Okay. So that the network convergence time is also reduced. So that's the reason OSPF is very much suitable for the large networks as well. Also in OSPF, cost is used to calculate the metric value. Metric value where we discussed earlier, right? PALM, which means PAML, in order to select the appropriate suitable route from the route table. Router uses the PALM, so which means prefix length first, which is the highest prefix length, then lowest admin distance, and then lowest metric value, and after that load balancing. This is the order we went through, and there to calculate the metric value, the cost has been used. Okay. And also you can see when you configure the static routing, you have done all the calculations regarding the known networks, unknown networks, and then you made a table and you assigned all the networks to the particular static route, right? Only the unknown networks you have advertised to each router. In OSPF, you are only specifying the known networks. You just go to show run or show IP interface brief on each router, and then you'll see the networks, and then you will advertise it to the same router. Okay? You don't need to think about the other router and how to reach the unknown networks and all. So when configuring dynamic routing, it's easier for administrators, right? Rather than configuring a static routing. So here the each and every calculations you did previously in static routing regarding the unknown networks and combinations, everything is going to be done by the OSPF protocol. Open shortest path first algorithm is going to do the rest of the work. You are just going to specify only the known networks to the particular routers. Okay. So in OSPF, the admin distance is 1/10. You might know already. And then cost has been calculated by, as I told earlier, 10 to the power 8 is the default value, constant. Okay. So you need to divide it by the bandwidth of the link. For example, here it has been shown, if it is 64 kilobits per second, you can divide the 10 to the power 8 by 64,000. Okay. Why these 3 zeros? Because kilo means 10 to the power 3. So by doing this, you can find the cost as 1562. Okay. And to select the best path, the shortest path first algorithm has been used. Okay. And OSPF, when introduced, is used the Dijkstra algorithm, and then shortest path first algorithm has been used. So OSPF, open shortest path first. So it's using the shortest path first algorithm. And the multicast addresses involved with OSPF are 224.0.0.5 and 224.0.0.6. Okay. So neighbor relationships established by hello protocol and router ID, which we will see in a few moments regarding the OSPF neighborship formation. Okay. So mainly hello packets are taking very much effort in forming the neighborship. Okay. So the hello protocol or hello packet is going to include the router ID, area ID, hello interval, hold down timer, stub flag, and MTU, which means the maximum traverse unit, and also mainly the maximum traverse unit on both sides of the link. For example, router 1 and router 2 are connected, means the in between links, the both ends, let's say it's A and B, the A and B must be in same MTU. Okay, which means generally the default MTU is going to be 1500. So it should be 1500 on both sides. Okay. And hello interval is 10 seconds. Dead interval is 40 seconds. Okay. Also that also should be matched. That should also be matched. Okay. And default priority of OSPF is 1. Also to avoid packet flooding and to reduce the network convergence time and make the performance better, area concept has been used in OSPF. Okay, that also I will explain in a few minutes. When network triggered or when there is a network change, the updates will be sent and received. Okay. So OSPF maintains routing table, neighbor table, and database table. You can visit our website for the commands in the videos. If you want to purchase other study materials like packet tracer files and other course guidelines, then you can email to us.